Got to give the people, give people what they want back. Alright, we're going to do a review of some things, talking about evens and odds. We just went over them real quickly. It's not super complicated. Want to make sure you get that. And then review some things that you need to be ready for your test on Friday. So, even and odd functions, domain and range, and composite functions. Please make sure you get all of this down. Alright? It goes faster when I write it beforehand, so I did it faster. Even functions. Here's an example of an even function. Alright? This is an even function because it has symmetry over the y-axis. It's like a mirror reflection, right? If I flip this over, these two, if I flip this side over, those two sides would match. They mirror each other across this y-axis. I think you talked about some of that stuff in geometry as well. Also, algebraically, you should know that f of negative x equals the same as f of x. We're not going to test you on that now. It's something you're going to need for pre-calc and calculus, but you'll talk about it again. Wanted to make sure that you had it. Okay? Odd functions. This would be an example of an odd function. This has rotational symmetry around the origin, right? So if I take the origin, 0, 0 right here, and if I was to rotate this thing 180 degrees, boom, this would line up and mirror this right here. Okay, so notice you would rotate around this 0, 0 point, spinning it like a clock. This becomes an odd function because it does that. So I want to make sure you had those down. Okay, your test, Friday. First part of that is going to be about domain and range. So let's look at domain. Domain ultimately is a list of all the possible x values for a graph or an equation that actually work. So if I want to go ahead and draw a picture that looks like this one here, so it's a 3 in each direction. I have something at the point -1, -2, and then it goes up and over. My domain in this one, if I'm going, it's my x values, so I can never go farther than here. So I have x, I have -2. It is included because the dot is closed, so I close the dot. This direction, I can't draw anything because this is going to keep going. So this one goes to infinity. Infinity cannot be included because I could never touch infinity. Yeah. Alright, so again, if I wanted to make these match up with the other type of format, I would make boom, it's touching, that's a -2. This is infinity and it's not touching, so it's parentheses. Remember, this goes with this goes with that. Here's one of those examples where you're not given the graph, but you're just given an equation. Honestly, when I look at these with an equation, instead of thinking about what are all the things that x can be, I like to think about what are all the things that x can't possibly be. I can put a 1, 2, 3, 4, 5. I can put any number in here I want. There's only one number that I can put here that would make this not work. What is that number? You were thinking, oh, it's 0, right? So my domain is x can equal all real numbers except for 0. You could write it just like that. That works for me. It could be any number in the whole world I could put in here and I would get an answer except 0. 12 over 0 is undefined and it does not work. So that's domain. Quick recap. Alright, let's look at range. Range is a list of all the possible y values now in a graph, or possible y values, outcomes in an equation. So in this part, I'm looking at this and I'm seeing range. Okay, so now I'm talking about y values. I see the lowest I ever go is right here on the y-axis. The highest I ever get to on this graph is up here on the y-axis. Don't let this part fool you because the graph goes higher than here. This is an open dot at -1, 2, 3. So this is -3. It's an open dot, meaning it's not included, so it looks like that. We're on the y-axis. I'm up here at +1, 2, 3. And I have a solid line, which is the same as a closed dot, which means it is included. So y goes between -3 and 3. That's my range. If I wanted to write it this way, negative 3 and 3. It would look like so. Finally, if I'm talking about range, all my possible outcomes, if I put 1 in for x, 1 squared is 1, then it becomes negative. If I put 4 in for x, 4 squared is 16, but then it becomes negative. If I put negative 4 in for x, negative 4 times negative 4 is 16, but then it becomes negative. I see my outputs will only ever be negative numbers. So I could say for my range that y is anywhere from negative infinity, right, all the negative numbers, to 0. But is 0 included? No. I don't want it to be included because I could have negative 0.000001, but it can't be 0 because 0 is not a negative number. Wait. Actually it is 0. 0 is included. Excuse me. Because it's not negatives, because if I put a 0 in here, 0 squared is 0, negative 0 doesn't include. So actually it goes 0 in all negative numbers. I actually just can't get positive numbers. So go ahead and change that. So 0 is included in this, actually. So from negative infinity to 0, which is basically 0 in all the possible negative numbers. All right, cool. Pause right there. We got one more thing. All right, here's our last piece. We're talking about composite functions. So you want to get this down. We have f of x, 3x minus 5. We have g of x, x squared again. You can pause to get that stuff down. I want you to show me f of g of x. Ooh, I'm actually going to change how I wrote this. We'll do that in a second. All right, I want you to show me f of g of x. Meaning, if you're thinking about how do I think about this, I'm putting g inside f. It always goes in there. So actually start with f. So f of g of x. I start with f of x, which is 3x minus 5, but instead of having that x there, so I put g inside of f of x. So right here, I put g inside there. So we now have g of f, or f of g of x, okay? There it is right there. I can't do anything else with it because I don't know what x is, but that's what it would look like. Here, I actually want you to find g of x. Alright, so that means I'm putting g of x inside g of x. So to do g of x, I know that g of x is something, it's x squared. When we get rid of x, oh my gosh, I'm gonna struggle right here. Sorry guys. G of x is x squared. So I'm gonna replace this with a g of x, and it has to be squared. The g of x that I'm gonna put in there is x squared. So I basically have x squared squared, which I could call x to the 4th. So g of x equals x to the 4th power. Okay? And then lastly, sometimes they'll ask you to evaluate g of f of 3. And again, I gotta remember, right? First, starts inside out. First, I put 3 into f. Then I take whatever that is and put it into g. So first I'm gonna look for f of 3. And f of 3 is 3 times 3 minus 5, which is 3 times 3 is 9, minus 5, which is 4. So now I take this, f of 3 was 4, and I go ahead and put it into g of x. G of 4 equals 4 squared, which equals 16. So g of f of 3 ultimately is 16. All right, that's what we got. That's our review stuff to get us ready for the test. You have some homework that you can still look at and classwork that you can look at to practice some things. Shout out to everybody in Mr. Tillis' class who held it down and weren't scared to volunteer, especially those of you who volunteered and helped make that video. I appreciate you guys for having a little energy. Y'all ain't never scared. You everywhere. They ain't never there. Bats, I'm out.